So, back when I was in college, our computer science professor would explain to us the concept of object-oriented programming using the example of duck. So, if we wanted to model different types of ducks and using the object-oriented approach, the way to do this is to create some kind of abstract duck class, right, that has some kind of general features. For example, swim and quack methods. And then if we have different types of ducks like wild duck, it could have a method like fly. And then if we have a duck like rubber duck, it could have a property like toy. And if we have Scrooge McDuck, it can dive into money, right? Like we all remember from childhood days. So the cool thing about this approach is that we can have this shared behavior between different types of objects, such as those two methods like swim and quack, through the parent class, and yet we can still differentiate them and have different behavior for each one of them. And none of the objects really clash. None of the behavior, none of the specific behavior really shares between them, only the general one. So rewind a few years forward. My friends and I, we decided to create a startup where you could, I'll show you a demo, where you could order your own apparel with custom design, right? So, for example, if you want to order some kind of a t-shirt, you can position your favorite picture of your favorite pet, do something with it, add some kind of text, and really, you know, anything. So we needed to create some kind of very nice interactivity for this sort of a site. And this was back in 2009. None of the websites back then used JavaScript to create this kind of stuff. Everyone was using Flash. The thing about Flash is that I don't know it, and I also love JavaScript. So I thought to myself, okay, I'm going to use JavaScript. But little did I know what I got myself into. Well, two options that were available to create this kind of interactivity were Canvas and SVG. The thing about SVG back then is that it was really buggy among browsers, and it was pretty slow comparing to Canvas. So you could see those demos back then where Canvas would completely outperform SVG. Now, the thing about Canvas is that it has a pretty low-level API. Most of you probably know about this, right? It has this like humongous context object, which is like a God object, and we have those completely low-level methods for drawing some simple shapes, some kind of like cryptic methods like quadratic curve 2 and Bezier curve 2 and God knows what else. So clearly, if we were to create the interactive application the way we needed to create on Printio, I had to make some kind of a higher level abstraction. So at that moment, I set on to build Fabric, which is a Canvas library that provides interactive object model on top of that Canvas element. The object model that was missing in Canvas, those low-level methods, those procedural methods that you don't really want to deal with. So just to give you an example of how Fabric differs from native Canvas and the kind of stuff that you can deal with native Canvas, let's say we wanted to draw a red rectangle, right, somewhere on Canvas. The way to do it on Canvas is to set some kind of fill style property and use fill rect method. Okay, you could see it's nice and procedural. The way to do it in Fabric, even though you can see that the example is a little bit bigger, is to operate on objects, right? So this is the approach that I described earlier, the object-oriented approach of really operating on objects where each object is its own entity. In this case, we create canvas, Fabric canvas. We create rectangle, another object, and then we add that rectangle onto canvas. Nice and easy. Okay, let's say we want to rotate that rectangle. What do we do now? Okay, well, with native canvas, what is that stuff? Radians, we need to convert degrees, translate context. You could see it's pretty bad. it's really inconvenient to work with native canvas methods. What do we do with Fabric? All right, we'll just add angle 45. That's it. And refresh canvas. Another example, if we want to move that same rectangle a little bit down, the way we would do it within Fabric is simply to operate on that particular object and then re-render the canvas by setting new left top properties. The thing about native canvas method is that we need to first clear the context, then call the method again, and you can imagine how fast it becomes like a real problem to a real like a gigantic issue of these methods piling up on top of each other and dealing with that context. Final example is something as simple as rounded corners rectangle. Again, we have those cryptic curve2 methods. We have to figure out those coordinates somehow. It's absolutely horrible. The way to do it with Fabric is by setting Rx, Ry. So this is the kind of stuff that I've set to build, and it's really a wonder to work with it right now, to work with this kind of interactivity using Canvas. Now, I mentioned OOP before, for a good reason. This is a very, very powerful approach. The way it works in Fabric is like this. When we need to render something on screen, what happens is Fabric goes over all objects and simply calls the render method on each of them. Now, notice that each object is an instance of a particular class. In this case, this is Fabric image, this is Fabric text, this is Fabric path group, some kind of a sequence of SVG paths. So the same way we can add a specific behavior to each of those objects by adding specific methods. And even though the method names are the same, the behavior is different. So each of those classes know how to represent itself, they know how the output that they need to provide, and yet they still conform to the same API. Pretty cool stuff. Now, if we were to look at the bird's view of how things work there in Fabric, is we have Fabric Canvas, which is that global canvas area where all objects are drawn onto. Now, Fabric Canvas can have many Fabric objects, and Fabric object is just basically a two-dimensional shape. It's that parent class, it's that abstract duck, right, that we saw earlier. And the subclasses that it has are all those simple shapes like polyline, text, image, rectangle, ellipse, and so on. We even have a third level subclass in here, such as path group, which is an instance of a subclass in the Fabric path. And aside from a couple of mix-ins, which I'm sure you're all familiar with, such as observable and collection, to give those objects things like event methods or collection methods, we also have, again, different classes that are responsible for filling those two-dimensional shapes with different things. So for example, if we fill rectangle with polyline, with gradient, we get gradient. If we fill it with pattern, we get pattern. And yet all of this is nicely encapsulated in different objects. So I'll just quickly show you a demo. This is our front page. You can see that obviously it supports simple shapes that I mentioned earlier, and we can move them on canvas, do different things with them. We also have complex shapes like this lovely cat. You can resize it nicely. We support images, obviously. This is that example of filling objects with different gradients. There's even support for image filters, where we turn this image into this kind of image by cloning it and then applying a filter. We have text, right? And each one of those objects is still a regular Fabric object. We have animation, support for shadows, grouping, right? So this is like two ovals and a text grouped together. And notice how we can work with it, right, as a one entity. Oops, The bug gets in the way. All right. Yeah, just like one object, even though it consists of 3. There are things like flipping objects, constraining the movement. There's events. I'm going to go a little bit more into it in a little bit. Clipping, there's that pattern support, and a little bit of free drawing. So, some of the goals that I set in mind to have for Fabric when I started building it. The first one obviously has to be that it has to be simple and intuitive. I'm talking about API, of course. So I want to look at the code and I want to understand exactly what's going on. And this is the example actually from one of the demos. Here's this kind of like an example of an animating clip. And this is the code. And I just use that code here to give you like a understanding of what's going on here, right? So if we look at it, it's pretty simple. Okay, there is some kind of image. We're loading it from URL. We pass in it a callback, pretty common idiom in JavaScript world. We scale that image a little bit. We set some properties. We set that clipping area. We add it onto Canvas and we set it as active. That's it, right? So we look at the API, we read it line by line, and we understand exactly what's going on. We don't need to think about different cryptic methods and different huge API that we have in Canvas and how to work with all of that. It had to be modular, right? So right from the start, we built it the way to have, to be represented as a bunch of different small classes. This obviously gives us a very flexible architecture, and it makes possible to have something like custom build, for example, where you could see here, you can go online and create your own custom build by specifying different modules. And the lowest sized could be as down as 77 kilobytes, which is really small by current standards. Latest jQuery is like 96, I think. And obviously, the flexible architecture, if we look at the examples here of some of the filters that you saw earlier, image filters, they're all just small files, right? They're each about 1-2 kilobytes. And it makes it really convenient to work with them, really flexible and maintainable. What else? It had to be encapsulated, okay? It has to play well with other libraries. It should not change anything in the environment where it runs. It should be all contained under one object of Fabric. And because of that, it really becomes cross-browser. Okay, I'm going to go into that a little bit later. Tests. It had to be tested. We have more than 2,000 unit tests, and we have all kinds of tests for SVG import, SVG export, anything really. We have obviously why do you need tests? Because in a browser environment, you're dealing with so many different variations, you're dealing with so many new browsers coming out, some behavior constantly changes, and you just need to have tests in order to save your own sanity. And because of this, cross-browser kind of comes on its own. We have a huge browser support just because we follow those two principles before, of keeping everything encapsulated, not extending any host objects, and having a vast test suite. We support Xcanvas, we support IE 6, 7, and 8 through the Xcanvas wrapper, which uses like VML. And another cool thing that we had to create right from the start, which is kind of specific to our startup, the way we had to do things, is that Fabric runs natively on Node. The way it does it is by using Node Canvas library, which relies in its turn on Kyra graphics library, which is available on Windows, Linux, Mac, really. So it basically can be shown anywhere. Okay, and I'm gonna give you an example. Here's an example of Node.js rendering Canvas. I have a server running here. Okay, on the 8124 port. And you can see that this is kind of like a test page where right here we rendered the rectangle on Canvas. And here we have an image which is returned straight from Node.js by passing it code, and then it runs Fabric on code and spits back the image. And we have a bunch of different test cases to see that everything works properly. Okay? So I'm going to quickly go over some of the key features that we have and things that really become possible when you follow this object-oriented approach and when you have this kind of power in your library. So first of all is built-in interaction, of course. This is something that sets us aside from other libraries of this type. You might have noticed earlier that all objects have these little controls, right, that allow you to manipulate them easily. So this is something that's built right in. If you build in an application that requires some creation of some kind of collages or some kind of positioning one thing on top of another, this makes it absolutely convenient to just plug it in, and you have this drag and drop support, you have the rotation, you have scaling, all kinds of stuff, even flipping. Oops, ran away from me. Come back. Let's try to refresh. All right, this usually does not happen. So the modifications are pretty vast. You can change the padding between the controls. You can change the corner size, change the border color, corners, things like that. You can remove borders or controls entirely and just keep it like this if you're working with some kind of transparent images, for example. So the customization options are pretty endless, and you can customize and do whatever you want. Another demo of customization where you can change the style of selection area, for example, or here's examples again of borders, controls, different things, and you can even, for example, completely disable group selection. So the options are really pretty powerful. So another thing that we have is SVG parsing. And this is really something that also not many other libraries have, and something that I wanted to have from the start is ability to take any SVG shape and render it on canvas. And we kind of did that. And you can see this test where on the right we have SVG. We can actually inspect it. Let's inspect this hen. Right, so you can see that these are different path objects that have this huge data strings that are all successfully parsed by Fabric, by our parser, which is right under 1,000 lines of code, and has these funky things like there was a regex somewhere here, can't find it now. There you go. Here's our huge, oops. All right, I gotta do this. Stay with me. So we actually parse all those cryptic properties from the SVG and recreate corresponding shapes. And this is what you see here. Right? So what else? Free drawing. We're dealing with Canvas, so clearly free drawing is something that has to be built in the library. I don't have example here open, but I'm gonna skip right to image filters and show you the power of image filters and the power of objects. So here we have a simple image object, right? That has those controls and everything that can be modified just the way we want it. Now, let's say we want to invert it. Okay, we applied invert filter there. Now, this still stays that same image object. You could still do anything you want with it. You could still, operate on it. You could access it programmatically, whatever. You can apply different objects, different filters here. Just an example of some of stuff that we have. We can pixelate it a little bit, right? Or give it a tint, maybe like lavender. There you go. Right? So image filters, and obviously the architecture again allows to have very flexible and very small files representing each filter, which you can add on your own. All you need to do is specify the method of manipulating each pixel, and there you have it. And you can just plug it in and still operate on image objects and just have your filter. What else? Animation. Okay, obviously animation is a really big thing, and it's built right in. Here's an example of some kind of particles, right? It just tries to get away from the mouse. So this is using, aside from being a pretty excellent benchmark of performance, you could see that it's using animation. And each of those objects is actually an image that's rendered by Fabric. You can see here that we create a new Fabric image. Another thing you can do with animation is create some kind of a demo like this, right? A solar system where Saturn moons move around it at a different speed, and you can hover over. Now, each of those elements is actually, the text is Fabric text, and the images are Fabric images, and then this is the canvas background there. And you can see how really all of those objects just come together, and they all work together, and it's really easy to work with them. The power of OOP. Here's an example of animating shadow size and image size, which gives us this kind of like an impression of 3D, simply because we changed the size of the shadow. So you can see that we can animate multiple properties at once, and really the possibility become endless. Here's an example of some kind of objects which animate inside, and notice how we can still work on them, move them, group them, right? And they just continue animating there. You can even rotate like this, right? So each object is concerned with its own animation, each object is concerned with its own rendering, and everything just works together simply because each one has that render method responsible for its own rendering. We can even animate like polygon points and create some kind of cool effects like this. Again, this is all limited by your imagination. I'm curious to see what you can create. So another thing is events. Events is a very major and very all-encompassing aspect. And having events in Fabric really allows for some cool things and very powerful things. So here's a demo of how we are operating on objects and the kind of events that fire with them, right? So like when we move the mouse down, it fires mouse down, and then mouse up, mouse move. Something is always happening. When we scale an object, you could see object scaling events rendering, and when we rotate it, there's object rotating events, and so on. And all events are scoped per canvas. So you can have even multiple instances of canvas and work with them completely separately. So the kind of things that become possible when you have events in your system is, for example, this demo, right, of a stickman. So the way it works is very simple. We have different circles and different lines. And you can see here that we are observing object moving event and then modifying the coordinates of the lines. And what we get is this cool impression of a stickman, right, where lines move correspondingly to the circles. This is the power of events. Another thing is, for example, we can observe the object moving event and check the bounding rectangles overlapping other objects and then achieve this kind of funky effect, right, where something overlaps and they just become like half transparent. Really, you can do anything. And what else? Here's an example of moving the mouse and objects becoming a little bit less opaque, right? You can use it, for example, to highlight certain areas of an image when you move an object. And these are all still just objects, not Fabric. And even if we move it like this, you see that it still works. You can imagine the kind of cool things you can achieve with this. So, all right. Now that we went over some key features, we have a few more things on the roadmap, such as curved text. We have, this is a really common feature that's been requested, and it's really cool to create a text that follows some kind of path, for example, or goes like in a circle. We have we planning to do multiple layers for performance, which is a very well-known technique. We want to do canvas zooming. We want to experiment with WebGL render, which is pretty huge right now. And finally, we want to do interactive text. I'm just going to quickly go over it because I think I'm running out of time. Here's an example of interactive text. So you saw here when I showed you the example on the front page, and I said that these are all Fabric text objects, even though they have very extensive support for different decoration and alignment and even multi-lines, which native canvas does not have, and Fabric provides because it's convenient. We cannot make, for example, the word even red, or we cannot put the cursor here and edit it right here in line. So this is something that we're planning to implement with, where is it? With the interactive text, where this is the concept that we're working on right now. It's almost finished, and you'll be able to do these kind of things right in Canvas, right? Like select it like this, or add new things. And notice that this is still the same text object with just more functionality. You can still work with it the same way, but you can also edit it. So this is going to be really cool, and we even will support like a word selection and different stuff. All right, so just a quick note about other libraries, the way Fabric compares to them. I have this table online where I compare different libraries I created a few years ago, and to see basically how Fabric compares to others, and to see whether some of them implement features that I needed. And that's when I learned that they don't have, for example, SVG parsing available, right? And that was part of the reason why I created Fabric. So right now, the main contenders are Easel, Kinetic, and Paper. Some of them you might have heard of. Those are the ones that have the closest functionality to Fabric, although they don't have as much as we have, and they're not as customizable, which is the result of those goals that I mentioned earlier, to be modular and to be to follow that OOP approach. Finally, the Pixie and 2JS, we have two newcomers who implement that WebGL renderer that I mentioned earlier, something that we're planning to look into. And the rest of them are pretty inactive, so it's just those few of them on top that are in the business right now. So some of the things that people build with Fabric is, for example, infographics designer. Right, it's perfect. You want to create some kind of charts, type some text, position some stuff, set transparency maybe. It works perfectly. You can just drag objects by default. It was beautiful. Another one, soccer formation board. Someone built that to create these like diagrams which players should attack other players, right? And like draw those lines and things like that. Someone created tutoring whiteboard where you can draw something on canvas and you can cooperate together, I think, even type some text, and even some games like arcade volleyball. I think we don't have many games, but this is one of them, one of the few that I saw. So before I wrap this up, I just want to say that open source rocks. Okay, back when I created Fabric for our startup, which is closed, no one kind of believed me, and no one really thought that this is a good idea. And yet, over 3 years, we have more than 50 contributors on GitHub. We have almost 1,000 tickets. Most of them are closed, of course. We have more than 1,500 commits. A lot of people following us on GitHub. A lot of discussion going on Google Group, and even more questions popping up on Stack Overflow. So notice that out of 1,500 commits, only 1,000 commits were done by me. So Fabric is truly a collaborative effort. Truly, a lot of people just chimed in and started to work on it, started to share it, and it's really amazing, the kind of stuff that you can achieve. We always welcome your help, okay? So you could do a lot of cool things, and if you like it, and if you find it useful in your project, I would love if you can help us. Maybe translate the tutorials, maybe create new demos, maybe help with design, maybe find some SVG failures, because SVG is huge and scary. Maybe fix some bugs, maybe improve docs, or just spread the word, you know, mention on Twitter or on your blog or whatever. So please keep in touch, follow us on Fabric. I covered only very little chunk of functionality. Go into demos, check out the kind of cool things that you can achieve with it. Follow us on GitHub or Twitter, and if you have questions, I'm here to answer them. You can find me on Twitter at Kangax, where I rumble about JavaScript and all that stuff. Thank you.
Thank you very much for the presentation, and we have really short time for the questions, only 2. So 2 quick questions, please. First here on the left.
Hi.
Hey.
Is it possible to resign older browser support in order to have smaller files to include?
Kind of like what jQuery is doing right now?
Once again?
Like jQuery is doing right now by cutting the code base to the modern browsers? Definitely, yes. And actually in our custom build, we have a way to exclude, for example, all the browser support for array methods and all those like ECMAScript, older ECMAScript methods, and only keep the ECMAScript 5 ones, right? That have those like map, reduce, all that stuff that we use. So it's possible already to create a little bit smaller build for newer browsers, definitely, yes.
Hi, does it work with some physics engine like Box2D or something like that?
Absolutely, because you have access to objects, you can do anything with it. So the way we animate, for example, object properties is simply by animating them, the values, and then you call the re-render the canvas, and it happens on the screen. So I've seen examples where people use it with physics engine, and it worked nice, yeah.
Okay, maybe I ask for too much, but can I set transparency color in the images using the filters?
Absolutely, of course, yeah. You can do anything because the way filters work, again, it's just a class, it's just a filter class that needs to implement one method, apply to, and that method has been passed an image data of pixels. So you can just walk over those pixels and change them any way you want. You can, for example, make every second pixel transparent, and then everything else is just going to work the same way. You can still operate on objects, and everything is encapsulated.
Okay. Question, do Fabric support touch events?
Yes, it does.
Okay, thank you for your questions. Unfortunately, we don't have any time.
Thank you.